the theoretical mic to you.
Okay, standing by.
All right, we're good to go with the recording.
Awesome. Welcome, everyone. Here we are at the Friday Tech Talk at the Tech Academy, and we have Don Anderson this week, who is a retired Air Force pilot who now works as an analyst for the Air Force in a civilian position, and he's going to share with us how they implemented data analytics, AI, machine learning to improve mission success in the Air Force. So we're going to see the inner workings of an actual application of data analytics. So I will let Don take it away. Thanks everyone for being here. Teach us some stuff, Don.
Okay, well, let me see if I can bring up my briefing here. And can you see my slide?
I can.
Okay, so good afternoon, everyone. My name is Don Anderson. I'm the Assistant Director of Analysis at Air Mobility Command, which is part of the United States Air Force. I am a retired pilot. Here's a little bit about my background. I flew C-130s, which is the airplane on the top right. I also flew KC-10 air refuelings, which is on the bottom right. Also during the Air Force career, I was an advance agent for President Clinton. And I was also a cryptologic linguist in the Air Force, Chinese Mandarin, and I also flew on the RC-135 aircraft. So this is where I work. We're part of a larger analysis group. We actually have 160 analysts and coders working in one place. We're 1/3 military, 1/3 Department of Defense civilians, and 1/3 contractors. We're located outside of Scott Air Force Base, which is outside of St. Louis. We're located at Scott Air Force Base, which is outside of St. Louis. Some of our skill sets are Python, artificial intelligence, machine learning, web applications, and deep analytics. So the picture you're seeing here is just a map of our Air Mobility Command flights in the year 2020. The blue ones are civilian aircraft that we hire to fly our material and personnel around. The orange lines, those are the military aircraft we use to fly in and out of Afghanistan, Iraq, and a lot of other locations. So the following story is still in progress, and it's true. I'm going to show you examples of how we used coders to help us attain our goals, build visualizations for military use, and design an aircraft selection forecast model that is, in our opinion, superior to anything in the civilian sector. So here's the problem statement. What you're looking at here is an aerial view of Charleston Air Force Base. And the airplanes that you can see, they're probably pretty small, but there's a lot of C-17 cargo airplanes. Those are big, giant airplanes that do nothing but carry cargo and passengers around. So let's just say that Charleston Air Force Base has been tasked to support the president visiting Europe. This will require 3 of our C-130s to fly to Germany. And which 3 C-17s have the least chance of breaking during this 10-day mission? In case you're wondering what we're doing with military aircraft supporting the president, here's a picture of the inside of our one of our C-17s carrying the presidential limousines around. So you can imagine if the president is going to stop at 4 or 5 different cities on a European trip, we need to get these limousines in place before the president comes down Air Force One. So he can get on these into these automobiles, which are bulletproof and bomb-proof and everything else. But it's just a safety feature that, you know, goes along with all the presidential duties. But having said that, if the president comes down Air Force One and the limousines aren't there, it's going to be quite embarrassing for both us and the United States. So failure is not an option. So let's just look at what we're presented with. 21 of the 40 Charleston Air Force Base C-17s are at home. The rest of them are off station, out doing other missions, you know, maybe flying in and out of Iraq or Afghanistan or something like that. So of the 21 aircraft, statistical analysis informs us that 6 of those aircraft will likely experience a mission delay due to a maintenance issue. This would cause the president to be, causing the president to be late is not an option. So we have to know which aircraft we're going to pick. And this is pretty much the bottom line up front here. Using artificial intelligence / machine learning, we can find out which 3 aircraft of the ones that are on the ramp would have the highest chances of having mission success, or put another way, which one is least likely to break down, while it's flying its mission. So the following slides inform us on how, using the coders and some AI ML tools, we chose those 3 aircraft. So we're going to start off with the data. Something that many of you are probably looking at right now at the Tech Academy are how to work with data. I'm not sure this qualifies as big data, but it is quite complex. First thing we have to do is take these 2 data sets and merge them together. This data set on the left is command and control data. It's about 50 columns and about 1.5 million records. The data set on the right are the maintenance history records of these aircraft, which has got 86 columns, and it's about 3 million records. So you can imagine when you merge these 2 data sets together, the file will become so big that most of Microsoft products would not open these files. It'll just say out of resources or the file's too big. So really, the only option we have right now is to use Python and to use what's called a CSV file. And there's some other things. There's no column that's the same in each of these data sets. The set on the left is event-driven, which means that every time an aircraft flies, you generate one record. On the right, these records are time-driven, which means a record is generated once a day for each aircraft, whether it flies or not. So you see, it's a little bit more difficult than just jamming these 2 data sets together. And then to add some more complexity, over on the left, we got multiple records per day per aircraft, and the serial number is an 8-digit format. Over on the right, we have 1 record per day per aircraft, but the serial number, which is the tail number of the airplane, is in 12-digit format. On the left, the date includes time. On the right, the date does not include time. On the left, we got multiple mission numbers a day, and on the right, we only have 1 mission number a day. And then, of course, the flight time on the left does not include time taxiing on the ground, and the flight time on the right does. So the bottom line is, rather than just kind of figure out how to push these 2 together, we had to use coders to put these 2 data sets together. We had to do it in a repeatable manner. And the only way we figured out to do that is to use some sort of code. And I know this is just a little piece of the sample code that was used to put these 2 data sets together. The bottom line, I'm going to stop right here. This may look simple to you, but I'll tell you what, for most people, this is out of their skill sets. Customers will pay a lot of money for this type of work, especially as something as important as maybe supporting the President of the United States. Or, also these airplanes do go into dangerous places and you don't want them breaking down, say at Baghdad. Or I'm sure you watched the news recently. We just pulled a lot of troops out of Afghanistan. The last thing we want is an airplane broken at an airbase in Afghanistan with no way to get it out. So this is quite important. And like I said, this code may not seem like much to you, but to us, it's extremely vital to what we're working on. Now, here's the data lineage of some of the maintenance data that we're looking at. And I don't expect you to be able to read these boxes, right? But each of these tan-colored boxes is labeled as a Python transform. Okay, and right now there's about 42 of them in the view right here. So the data is a bit more complex than what I just said. However, every one of those tan boxes required people to sit down and write code to get this into a form that we can feed it into the more sophisticated data that we're looking at, or into some of the more sophisticated software platforms. So bottom line is this: we couldn't have done any of this without what appears to be basic Python code, but something that a lot of people don't have the skill set to do. So our coders were the key linchpin to getting this program started. So if you see the arrows here, these are the Python transforms. I only highlighted a couple of them, but like I said, there's 42 transforms in this one look alone. Okay, so I'm going to build on this slide here and explain to you how complex picking an airplane really is. So we can gain insights using artificial intelligence / machine learning that we couldn't have just a few years ago. So in order to choose the C-17 aircraft most likely to experience mission success, We have to choose between the 21 airplanes that are on the ground. Those airplanes can fly 7 different mission profiles. So right now, we've got 147 choices to choose between. We also have to know how long it's been since each of these aircraft have gone through major maintenance. And we broke those into 10 different bins. In other words, so many days since its last major maintenance. And then we also broke the aircraft down by how old they are. Newer aircraft more likely to perform a little bit better than the older aircraft. So when you add in those 2 factors, now we're up to 14,700 choices. And we can fly to 6 different regions of the globe. So now we're up to 88,200 choices. And you can see the complexity of this is building pretty quickly. And it's also more complex than most human beings can even comprehend. But finally, there's 516 different airports we could choose from in Europe alone. That means we have over 45 million combinations to choose from. The only way that I know that we can do this is to use a sophisticated piece of software. All right, so because there's 45 million combinations of inputs to determine the best aircraft for this mission, aircraft choice in the past was simplified by using a few filters and the opinion of senior maintenance officers on duty that morning. So here's the foot stomper. With AI ML, we can do better, much, much better. So let me recap real quickly. In the past, we just got a list of airplanes that were essentially not broken that morning. And of those 21 airplanes, the senior maintenance officer on duty that day would say, I think we should pick these 3 airplanes because in the past they've performed very well. Well, that's not the best way to do things, because airplanes that performed well in the past may be getting older, maybe are coming up in terms of they need an inspection, or maybe it's time for an engine change, things like that. With the way we positioned this data and with all of the Python transforms, we set the data up in a way where we can feed it into an AI ML platform and come up with some pretty good answers. So I am not an expert in AI ML, but I know enough to use software to make actionable real-world decisions. Even if you don't learn much about AI ML, just the basic knowledge of what it does allows you to transform data into an input easily digested by the software that I'm about to demonstrate. That is exactly what my organization did for this project. So right there is a screenshot of some of the AI ML software that we're using. And these circle here shows the algorithms that we can use. These are the available algorithms. The top one just says GLM. So when I Google GLM, I get this. Okay, and this is just a screenshot of my Google. And this shows you how little I know of the AI/ML world. When I look at the definition, I'm pretty sure it's written in English. I do see a lot of really cool charts, but they don't really mean much to me. So what I'm telling you is, with the right data presentation and the right software, we can actually make some good decisions using something that really I don't know a whole lot about. So rather than process all this data before ingestion into the software, some of the data we can process after we bring it into the software and make things even simpler. So this allows for a simpler, easily repeated data prep, as we described a little bit earlier. All right, so I've got 5 different filters that I'm using within the AI ML software. Now, those transforms I talked about, we're still using those transforms, but there's a few more filters we need to do. But rather than go back to the coders every single time, we'll bring the data into the AI ML software. And on the right are 5 actions I'm going to take before I even start asking it for an answer. So I want aircraft not in depot status. So depot status just means an aircraft that's in its big giant maintenance cycle. I only want aircraft that are fully mission capable, meaning an airplane that doesn't have any write-ups. So it's kind of like when you drive around with your check engine light on. Well, we can do that with airplanes too, but we don't want to do that when we're supporting the president. So we want only aircraft currently fully mission capable and do not have their check engine lights on. We want aircraft that's more than 14 days since its last inspection, because after a big inspection, sometimes the airplane needs a few flights to work out the kinks. It's kind of like if you bought a car, a brand new car out of a factory, you might want to test drive the car first before you drive it home, just in case something goes wrong. We want aircraft that perform well in Europe. And of course, these yellow boxes are lined up with the choices that we're making within the software. And then finally, I want aircraft that are owned by Charleston Air Force Base. We might have 21 C-17s on the ramp there, but maybe one or two of them belong at, say, Travis Air Force Base in California, or out at McCord Air Force Base up in Washington State. So we just want the airplanes that are owned by Charleston because they're at Charleston, and the people that maintain the aircraft are at Charleston also. So we've essentially started whittling down this 40 million choices just by doing a lot of the filtering before we run the software. Now, this circle here tells us which correlations or what factors have the biggest effect on our maintenance improvement. So I'm going to go down and show you these, but you can see the percentages. Once again, you'll see like a 2.3% improvement or a 1.7% improvement. It doesn't sound like much, but these little improvements add up to big results. So for example, this is some of the insights that we're getting from our software. And just remember, there's 45 million combinations. But on the top left, you'll see time since last inspection. And those bins, they're too small for you to see, but they'll say something like 14 to 28 days since last inspection, or 29 to 40 days since last inspection. But if you look over on the far right, there's two columns that are very tall. We don't want to pick an airplane that has been out of the inspection cycle for more than 180 days. So that's extremely important. So we can eliminate a few of the airplanes on the ramp if they fall into those two categories. On the top right, these are what they call type of mission. So there's something like highway driving that you can do in your car that doesn't really cause much maintenance. But then if you want to take your car down a dirt road that's bumpy and it's got a lot of hills and stuff, that's really hard on the car. Same thing with the airplane. You put a bunch of heavy limousines on the back, and if you have to land at an airport with a short runway, you're going to have to land kind of hard. Rather than if you have a light load in the back and you're going to land at Frankfurt, Germany with a 12,000 foot runway, you can really land smooth. So this tells us which mission types we want to pick. So if we have, like I said, with the limousines, that would be one of those mission bins. On the bottom left, some airports can support our airplanes better than other airports. So you can see on the bottom left, the lower bars mean that those airports are better positioned to support our airplanes, and the higher bars are not. So we can eliminate a lot of the airports to bring the limousines into. It might be because they have better maintenance for C-17 aircraft, or they might have U.S. Air Force personnel stationed at them, or there might be a lot of parts stationed in that area around that airport. So there's a lot of different ways we can choose our airport. And then, of course, in the bottom right is the historical reliability of each aircraft. Once again, down is good. So we want to pick the blue, the airplane serial numbers that are in the blue that are low. But rather than going through manually and looking at all of these different categories, we come back to our software. And there's a little blue dot within that red circle. You probably can't see it, but it says actionable and it says serial number. So all we're doing is we're telling the software, hey, I want you software, AIML software, to pick which serial number is going to have the best chance of mission success. And you can see there's 3 serial numbers up here. Oh, first of all, I also wanted to say this is what's called a service mission. And we also picked the airport to be Ramstein, Germany, which is one of our better airports. And so we actually did some of the choosing for the software. And this is quite important. There's no such thing, or I would say artificial intelligence and machine learning will work a lot better if the human beings and the software can share insight. So one of my insights for this mission was I wanted to pick what kind of mission it was, and I wanted to pick the airport I go to. And then I let the software pick the rest of it. And so aircraft 900009212 is the best choice for the mission. And I have it circled in green. And by choosing this aircraft, the not mission capable time, which is another way of saying the broken time, is reduced by 1.2 hours, or approximately 5%. This may not seem like much, but a 5% improvement in aircraft performance is very significant. And then here's our choice number 2 and our choice number 3, which also gives us a 1.8% and a 1.6% performance improvement in our mission success rate. So really, that's what I have to show you. But in conclusion, the new AI/ML software is great, but it's not very useful unless you understand what it does. So what I'm suggesting to you is you don't have to understand the algorithms behind AI/ML, but you do have to understand what the purpose of the software is. And understanding the basics helps you to code better. What should the data look like after I transform it? The next big point here is the demand for basic coding, which is, Python, etc., is huge and growing every day. And really, I'm going to stomp my foot here. What seems like simple stuff to you can have a significant impact, like a Python transform or a Python data join. And the current demand for coders is insatiable. You may have to decide where and how much to transform your data. So in this example, some of the transform was performed in the actual software to allow for human input. And some of it, like I showed you, was also performed with coders that built a Python script to get the data to join together into a form that we can ingest it into the new software. So with that, I'm going to turn my screen back and stop sharing and see if there's any questions for me.
Yeah, so Eamon, if you want to ask a question, just go ahead and unmute yourself. Go for it.
Could you hear me all right?
Yeah, I hear you.
Perfect, thank you. So I just wanted to ask a simple question. Like, how long does that, the calculation actually take? So once you had all the data, the tables joined, and you had all the parameters, how long did that all take? Was it a second or take
So we were pushing through about 3 and 4 million records into each run. I think this software ran anywhere from about 30 seconds to about 2 minutes. We are looking at some larger data sets with about 250 to 300 million records. But right now we haven't got there yet. So when I say those big data sets, we're actually going to take some black box data off of our airplanes and run it through the software. So we're looking at a sampling rate of eight data points every second on various sensors through the airplane. So we're not sure what's going to happen on that one, but we'll see. We're going to push this to the limits.
Thank you.
That's really cool. Yeah, using all of those various black box data points. I'm curious if people are interested in looking for jobs in this sector. Where do you recommend people go to find jobs, in the military or the civilian military, through government entities and whatnot?
So if you want to work for the government, usajobs.gov is the #1 place to go. And I would say this: don't be afraid of what the qualifications say. And here's why. We post a lot of jobs, and a lot of times they'll say we want a 4-year degree, but nobody applies that has a 4-year degree. So we'll just say, okay, can you code? And we'll interview you. And if you code, you're hired. We're currently in the process of hiring right now at Scott Air Force Base, but this is DoD wide. There are more coding jobs on USA Gov than we can find applicants for. We're starting salaries probably about, $65,000, $70,000 a year, but it goes up pretty rapidly from there. And the reason why it seems kind of high for a government job, we've been hiring folks in, and then after a year or two, they move off to industry to make even more money. So we've actually upped the game a bit in the government to try to hold on to these people after we've trained them and they understand what they're doing.
Thank you for that. I see a question in the chat box. Ricardo asks, are there any other Python frameworks you use on a daily basis?
So there are lots of Python applications that are being used all the time. One of the things that, so we get a lot of projects that end up going in front of a lot of congressmen and their congresspeople. One of the projects that's kicking off right now is, okay, we want to cut some of our maintenance budget. What kind of impact is that going to have on our reliability of our airplanes? It doesn't sound exciting, but I'll tell you what, it's an exercise in big data. And you know, when you can't even open the files with Microsoft Office products, you have to turn to folks that have the skills that you're teaching out there at the Tech Academy. So that project just kicked off yesterday. We suspect we'll be up full up and running probably in about 2 or 3 weeks. And we've got 2 people on that project already.
Very cool. Ricardo says thank you.
Oh, you're welcome. That's a great question.
Yeah, and I noticed just from the code piece that you put on there, like pandas, which is just, you know, a Python library that's used for data analysis. Learning pandas is really important.
That was actually code from a couple of students, by the way.
Nice.
Yeah, so we do sponsor some students from time to time, and that was a student project. And so we've actually formalized that project itself, and we're going to go forward and see if we get some more funding for that project. And obviously we will, because the payoff is enormous. Having a broke airplane out in Europe or something just costs so much money to repair. So if we can get the airplanes home without breaking, it'd be fantastic.
So I'm curious, Don, when back in the day before we had all these analytics for the president, how many data points were there? I know you say there's 45 million now that is used, and then it's simplified for the people to make the choices. But back in the day before this, what was kind of the analytics they used?
So I kind of alluded to it. The analytics was basically the old crusty maintenance chief walking around the airplanes every day. They had in their mind, or you know, the experience that, hey, this airplane performs very well. This is the one I'm going to keep going to. The problem is they keep going to that airplane until it starts breaking, and then now all of a sudden they need to move on. So the analytics were not very good. Even the black box data from 10 years ago produces files so big that, I mean, just transferring it over to us would take weeks, right? And now we can bring it in a matter of minutes. So it's a whole different world when it comes to using big data to make decisions. But yeah, the data analytics was a couple of filters and a couple of smart folks that have been working on these airplanes for 20 years.
And a lot of intuition.
Yep, and that's what I don't want to get away from and move completely towards ML AI applications. It's the interaction with the humans and the software that creates the synergy. If you went completely with the humans, you're going to miss. If you went completely with the analytics software, you're going to miss. But put together, it's actually a powerful tool.
I think we had another question in the chat box. Marcus asked, what do you see as the future of analytics in this space in regards to additional AI/machine learning capabilities?
Okay, so that's a great question because it's a hard question to answer. And here's why. A lot of, and this is not to put down CEOs and leaders of companies, but a lot of companies don't even know the capability of AI/ML. So a lot of this is going to have to bubble up from the bottom, right? It's going to be folks that are young that are providing the new ideas. So we are educating our leadership by sending them through courses at MIT, just so they'll understand what AI and ML can do. But the future for us is just endless. We're talking about, I was talking before this began, big drone airplanes are going to take the place of the humans in our, warfighting capabilities. Just like you see the automated driving cars. It's actually easy to automate an airplane easier than it is to automate an automobile because you got less distraction. So Yeah, the future is coming quick, and that is going to be, remotely piloted vehicles, and that is AI ML, because you have all the processing, the visual processing, the language processing, everything else that runs through it. And so, in order to make all of that happen, we need gargantuan bandwidth and capability. I don't see, how Microsoft Office products are even close to keeping up, right? So we need to move forward with the new software as fast as we can and do these smaller projects like I just described. But once we get folks, in the leadership positions on board, then this is going to accelerate even faster. The capabilities are going to far outstrip our ability to actually use them. But so just a couple of the areas, though, is the automation that we're going to see within the Air Force itself.
That's interesting. I also hear like kind of the opposite, that some people in leadership, it's like there's a lack of understanding of AI and ML technologies that either leads leadership to ignore them completely or to like misapply them. So I've heard a lot of data scientists and analysts being asked to produce insight either with like no good data sets to start out with, or data collection practices, or for applications that don't actually make sense with an AI or machine learning model. So it feels like it's definitely up to the people learning those things to present the case for them as well to leadership.
So good comments. What we want to do, okay, so we just had it like a kind of an airplane selection project, right? But we want to take and put that side by side with the maintenance person that makes the choices. And we're going to do a side-by-side test of the maintenance person using the software and then the maintenance person without using the software. And if we can show the actual increases in our capability, there's going to be a lot of people looking at this software and a lot of people saying we need to implement this now. And so I suspect that the commercial airline industry is going to be looking at this long and hard also. So this is going to be a far-reaching test, but we want to get this test underway in the fall. And I think it's going to be the way to convince folks that, yeah, this is a useful product. And you also are right. There's a lot of misconceptions of what AI ML can do. So a lot of folks don't actually understand what they're asking for.
And then I think we have another question from Ricardo. They asked, what is a typical day for new hires? Is there a lot of supplemental education and training?
So it depends on where you come in at. We do have coding schools that are available for our folks, within the Air Force, so they can understand the Air Force data, and we can get them familiar with all of that. But a typical day for us, for the new hires, will generally try to understand what their strengths and weaknesses are. So rather than just say, you're going to sit down and you're going to do this task, we'll try a variety of different tasks and codes and things on them and see where they excel. And then we'll fit them into the correct projects, because we want everybody to work towards their advantage skills and kind of, not be forced into, forcing a square peg into a round hole. We want to actually fit them into what they're good at. So some folks are very happy working remotely and coding. Other folks really want to get out there and interact with the folks that are using the software. So it just a lot depends on the person that we're hiring.
So Don, would you say it's probably the last generation of manned fighter pilots, or with the F-22 and the F-35, and then going forward, it's going to be drones?
I'm going to say, so that's a hard question to answer, because I think the nature of our drones are not just going to be an unmanned version of an F-22. I think they're going to be, it's going to be like a network more than just individual airplanes. So I think you'll see a combination of manned and unmanned vehicles working together in the air, because you still want that human in the loop, at least for now. And there's also a lot of other factors that we got to consider before we run forward, because if you all of a sudden have fighting weapons and you have no chance of losing life, it's a little bit different than actually sending humans into something like that. So I don't know how to answer that, because there are ethical questions that we haven't figured out yet.
Yeah, I understand that. Another question too, how much, I know you're talking about the commercial industry with AI and ML. It seems like there's a lot of with commercial aviation, there's so many less accidents now than there has been in the past. And I know part of that is navigation and just the advancements with that. But with planes, when they decide what planes they want to use, what planes need maintenance, it seems like there's a lot of AI that goes into commercial aviation now.
Yeah, there is. And I think we've got to think beyond the let's just make our Southwest Airlines model of the airline more efficient. I think we can expand this into much more targeted flying, much more efficient flying, faster flying, higher flying, get away from the let's all drive to the same airport kind of thing, right? There's going to be some distributed transportation that AI/ML is going to enable to do things that we can't even think of right now. But I do think airports are going to be outdated in a few years also.
Interesting. So what do you see replacing them? Just like a more distributed network that doesn't have to be concentrated in large population hubs and doesn't have to be manned by as many people?
Just look at what Uber did to the bus system. I mean, it's fantastic. I love it. But I see my buses driving around town, and I'm lucky to see 1 or 2 people on them now, because Uber has become so distributed that almost everybody can use it. So something like that. I'm not going to say we're going to have Uber in the sky, but transformative ideas are just around the corner once folks understand really how powerful the software is.
Are they working towards like having commercial flights be drone flights, like passenger airplanes, or is that more in the future?
I don't know. They just did the space flight without a pilot. It's just a couple of days ago, right? So if we can go to space without a pilot, I personally wouldn't have a problem flying to Portland on an airplane without a pilot. I think it'll be possibly almost another generation before everybody will accept a pilotless airline, but that's coming.
Yeah, it's really interesting that you said it's easier than cars, and I hadn't really thought about that, but it makes a lot of sense that there's just less obstacles that you have to account for.
Yep, it's amazing, but yeah, cars have to do an enormous amount of processing to stay safe, whereas an airplane, big sky, little airplane, it's not that hard.
Yeah, I always try and tell people when they think they can't pick up a new skill, if they know how to drive, remind them about how difficult driving actually is and dangerous.
Oh yeah. And then there's a lot of folks my age that are picking up the new skills too. So.
Mm-hmm. And Brian just mentioned in the comments or in the chat box, I wonder if railroads are looking at this.
I sure hope so, because if you do any research on the railroads, their classic problem is they end up with a bunch of empty rail cars on one side of the country, and they need to be able to move things back and forth. And just the optimization problems that they've done in the past, I think there's a lot of room for improvement there too. And you see the same thing with big airplanes coming over from China. They come over full and then they go back empty, or not empty, but less full. For Valentine's Day, all the flowers come in from Europe, and then the airplanes like, now what do we do with these airplanes that are landing on the East Coast? So yeah, there's a lot of efficiencies to be found everywhere.
Well, this has been really fascinating. And Brian said container ships need this big time. Yeah.
Yes, they do, because the ships have the same problems.
Yeah, it's almost like there needs to be an umbrella organization of logistics people that aren't attached to any one company that can connect these different manufacturing and shipping companies with the cargo and transportation needs.
Yeah, so the big logistics companies try to do that. They're called the multimodal companies, but that's a classic problem in the military too, because we source things from everywhere, and then we consume it, and then we have a bunch of half-empty airplanes flying back home. Extremely inefficient. So we can get more efficient, I'm sure.
All right. Does anyone have any other questions for Don?
No. I enjoyed it. It was a good talk. So hopefully it was a little bit interesting. But yeah, thank you all for attending. I appreciate it.
Thank you so much, Don. It was really interesting. I can put my email in the chat as well if you're okay with me sharing the slides with people, if people want to grab that slide deck.
Please.
And then I think Ricardo might have a question. Ricardo, if you want to unmute yourself, go for it. Oh, accidental button press. No problem. So yeah, my email's in there, kenzie@learncodinganywhere.com. Thank you so much, Don. Oh, Eldred said, what's a good filter to use to look for jobs on USA.gov?
I'm not sure. I would just start putting in some coding terms and see what comes back.
Developer, engineer, software.
Yeah. Even put in Python and things like that.
Data science.
Yep.
Analytics, analyst.
Yep. And like I said, don't be afraid of the qualifications listed. Apply anyway.
No, great talk, Don. Thank you very much. And yeah, we definitely would like to have you back in the future.
Okay. Yep. I'll be here. See you all.
Awesome. Thank
All
you.
right. Thanks, Don. See ya.
Oh, just a note to everybody. Angela posted in the chat box that they work at Salesforce, and if anyone is interested in chatting about job opportunities, feel free to contact them. I'm going to write your name down, Angela. Are you? Oh, perfect. Can I find you on LinkedIn?
You can. Yes. So feel free to contact me if anyone has any questions of what it's like working at Salesforce. I'm happy to chat. So.
Awesome. Thank you so much.
You're welcome.